Hello guys, welcome to my channel. So as you have already seen the thumbnail, you know what we are going to do here. So I won't waste much of your time. Before we actually kickstart this video, let me show you the demo that we are going to build here in this video, and then we will talk about it. So this is what we have to build in this course. So the first mapping is your publish message mapping. So when you click send, a message is sent to Kafka successfully, and in the Spring Boot application you see that the consumed message is Demon Slayer Infinity Castle. And if you do more messages like this, like let's say hello Kafka sent, you would see that it is consuming all those messages. But how would you know? You have a get mapping to see all the messages which are being stored currently. If you click send, this is the history, and if you see the order, it is having the order from the beginning. So whatever you have inserted in the beginning, that is going to be kept first. Now we have a count mapping as well to count all the messages inside a topic. So when you click send, you have only two. If you have to search for a keyword, basically you want to find out a message having a keyword, then you can do that and it is going to work just like that. Let's do hello and it will give you hello Kafka. Now there is a delete mapping for clearing everything up. So when you click send, message list cleared, and you would see nothing. So get is returning 0, count is returning 0, and obviously keyword is not going to return you anything. So this is what we have to build in this video. So let's work on the code. Alright, so now you have seen the demo of the application that we have to build. It's very simple because we are going to keep everything simple. Now let's work on it from scratch. So first thing first is that we need to create a new project, and for that we need to go to Spring Initializer. Alright, so now here we have to do some customization like your project name. So let me give it a name, Kafka Demo, and we are going to go with Java 21 for now, and the latest version of Spring Boot 3.5.4. We can also use Spring Boot 4, but let me go with 3. Now what do we need? We need web, because we need to go with RESTful services. Then we need Kafka, obviously, so use Spring for Apache Kafka. And let's explore this. There is not much here, we just have web and Kafka, that's it. Just hit download and let me extract this. Now the first step is done, that we have generated the project. Now we need Kafka. So if you don't have Kafka installed on your system, let's go to the official page. So this is the official page of Apache Kafka. You can hit this button up to download Kafka, and you see that these are the versions available for you, right? Similarly, what you can do is just click on get started, go to quick start, and here you see that it is a step-by-step box, so which you can follow. So once you are done with the download, then you have to extract, then go to that folder and do these steps, right? So I'm going to follow this, and so should you, right? So let's go to this download button. Now here you don't have to bother about which version to download. Just click on this because this is the suggested version by Kafka. So just hit this, and it is downloading for me. What I would do is I would just double click on this, and as you can see I have the folder ready for me. Now I just need to follow the steps. So let me open my terminal. These kind of steps are going to common for Windows and any other operating system. You don't have to worry about what you have to do for each operating system, so they have kept it very simple. Now I'm currently at my location there, so I need to go to downloads, and inside that I have to go to Kafka. So I have two folders, one is for Kafka demo and another one is for the installation. So I would choose this, and once we are done with step 1, what we need to do is we need to set this. So let's quickly copy this and paste it here, right? So it has set a variable for Kafka cluster ID. Now we have to provide this variable to format log directories. So let's copy this, and here you can see that this is the variable that we have just initialized. Now paste it. Alright, so formatting dynamic metadata voter directory, and this is the path with metadata version this. Alright, now we are done with everything. Now we just have to start the Kafka. So let's copy this line, paste it, and hit enter. Alright, so as I can see, Kafka server started, and if you go up you can see the properties of the Kafka. These are the properties, and where are these? These are in the server.properties file, which you can open in case you want more information. So there are a lot of properties here, right? So you can take a look, but the important thing that I wanted to highlight is that the Kafka is running on 9092 and 9093. Alright, so this you have to remember because this we have to use. Now we are done with our first step. Now let's work on our Java project. So for this you can use any IDE, whatever you prefer. So I'm going to go with Eclipse for now. Alright, so let's import. Let's wait for it. Alright, so the project is imported and you don't see much here. This is your main application. In the resources you would see properties file, and in the maven dependency you would see whatever we have imported in our form.xml. Alright, so it's not much. You have Kafka, you have web, that's it. Now I would prefer to use YAML here. So let's rename this to YAML. Now let's open this and let's do some modification. Now for Spring or Spring Boot we don't have to do anything. If you want to change the port then you can do it, but otherwise there is not much that you have to do. Now for Kafka we have to do a lot of things. So first is your Bootstrap server. So let me first create a hierarchy. So Spring, Kafka and Bootstrap servers, localhost 9092. So this means that the Kafka server is running on port 9092, which is how you specify, and this is required for both the producer and consumer to connect to the Kafka cluster. I'm not going to go in detail about what is a producer, what is a consumer. I'm assuming that you already know about Kafka. So just to give you an overview about producer and consumer, so think of producer as a juice making machine. So this machine makes different juices like orange, mango. Mango is basically a shake, but think about it as a juice, or apple, and puts them so this machine makes different juices like orange, mango or apple and puts them into bottles. Now it puts these bottles on a conveyor belt labeled juice shelf, which is your Kafka topic, right? Now consumer is the delivery guy. So the delivery guy picks up the bottles from the juice shelf and delivers them to customers. Alright. You can also think of as a restaurant where you have a chef making items and providing it to a table, which is your Kafka topic. The delivery person or the Zomato guy basically uh, picks up that order and delivers it to you and you being a consumer. So this is like producer produces, consumer consumes, right? Simple real life analogy. So that's how it works in Apache Kafka as well. Now there can be many producers and there can be many consumers, right? So this also happens in Apache Kafka. Now this was very simple. I don't want to go any deep. Now the first property is again to specify where your Kafka is running. Now we have to give properties for consumer. So let me quickly copy paste that and then we will explain. So why do we have consumer? Let's first talk about that. So this is for your consumer configuration, and this section configures how your app will consume Kafka messages. Now group ID in this case is your consumer group ID. Kafka uses this to manage message delivery. All consumers with the same group ID share the message load for a topic. Alright, now here things get a bit tricky. Auto offset reset tells Kafka what to do when there is no initial offset in the group. So this can only happen when you are running your app for the very first time. So this property is for that. Now why do we have earliest here? So earliest says that start reading messages from the beginning of the topic. Beginning is the key here. There are other options on this property like latest, which means that start reading messages from the end of the topic. And then you can also specify none, which will obviously going to fail your application if no offset is found. Alright. Now key deserializer. So Kafka needs this to deserialize incoming message keys. This tells Kafka to treat the key as a string when receiving data. Alright. Now when we have a key deserializer, we have to have a value deserializer. Similarly, this tells Kafka to treat the value of incoming messages as a string. Alright. Now we have to provide the properties for producer, similarly what we have done for consumer. So let me quickly copy paste that and then I'll explain. So here we don't have much. So this only going to have your key serializer and value serializer. So the definition states the same for both consumer and producer. So we don't have to explain it again. Now we are done with the properties. So let's save this. Alright, now let's remove this default. We don't need that. And let's save this. Now here we cannot give tabs, we need to keep two spaces like this. So let me modify that. Alright, now we are good. So the first thing is done, that we have set everything up in the properties. Now we have to actually work on our code. Alright. So as I said, we have a consumer, we have a producer. So let's work on these classes first. So let's name this producer service. Now as this is a service, so we have to annotate this with a service annotation, and that is very obvious. Alright, now what we need is we need a Kafka template. So private final Kafka template, and the key is going to be string. You remember we talked about string key values before in the properties. This is where we get that information, right? So Kafka template. Alright, so this Kafka template is a helper class from Spring Kafka to send messages. It's like a mailman who sends your messages to Kafka, and the string means both the key and value of the Kafka message are going to be of string type. Alright, now we have to initialize this value, and how do we do that? We just need a constructor. So let's generate that. Let's remove super, and we are good. Now we need a topic name for Kafka, which means that where you are actually sending your messages to. So let's initialize that variable. Because this is a private static and final, this is going to be a constant, so it's going to be in all caps. And let's name this Kafka topic. Now if you're wondering why do we need topic, so think of Kafka again like a message post office. Producer is like someone mailing letters, and consumer is someone receiving letters. But the question is, where should the letter go? A Kafka topic is like a mailbox or channel, right? That's where a topic comes in. So a topic is responsible to organize messages, let consumers subscribe to what they want, enable scalability and parallelism, decoupling between systems. So topic is pretty much doing everything, because without topics everyone could get everything, which is going to be a total chaos, right? So that is why we would require a topic here, and which we have initialized. Alright, now we need a method. So producer produces a message. In that sense, it is going to send the message to the Kafka topic. So for this we need a method. So public void send message and string message. Now how would we send this message? Who will help us, right? So for this we need to use your Kafka template. So Kafka template dot, here we have a method to send a message, and here we just need to provide the message like this. Now you don't just provide message. Again, like I told you, we would require topic here, like where your message goes to. So here you have to specify that topic. Alright, so currently all of our messages are going to be going to this topic. So think of this topic as a default topic. Now we are done with our producer. Let's work on our consumer class. So new class and consumer service. Let's annotate this with service. Now producer produces a message, as in sends a message, and consumer consumes a message. So here we need a method consume. Again, this is going to have a message variable, and here we can simply just print sysout, consumed message. Now you might be wondering, where are we getting this message, right? So for that we need to use a listener. So we have a Kafka listener annotation. Again, the definition is being stated by the name. So here we need to provide the topics on which you want to listen. So for our scenario we have only one topic, which is Kafka topic. You can use this as a variable as well in the properties, and then a group ID. I'll explain why we require group ID here. So first of all, this is a service, so we annotated this with as service. Now Kafka listener is doing here the main functionality. So this is the magic part. So this tells Spring that the following method should be used to listen to a Kafka topic, which we have to specify here. Now this is the topic name that we have to search for, and it listens for messages here. Now group ID, this is the consumer group ID, because multiple consumers with the same group ID share the message load. So if you change the group ID, a new consumer group is created and it reads from the beginning, which we have configured, right? So why do we have group ID here? Because this listener belongs to this group of customers. So think of an example, think of pizza delivery. So imagine a city where people are delivering pizzas from a central kitchen, So group A, let's think of as a North Zone team, group B as South Zone team. Only members of group A get delivery orders meant for North Zone. Orders are split among them and no one repeats the same order. In the case of group B, a separate team with a different group ID, they also get the full list of orders from scratch separately. Now, why do we have two groups here? So this helps us to share the load. So if you have multiple consumers with the same group ID, Kafka splits the messages between them, and this is what we call as teamwork. So this allows parallel processing, boosting performance. This also helps in avoiding reprocessing. So Kafka tracks the last message read, which is your offset for each group ID. So if a message has been read by group ID equals to X, Kafka won't send it again to the same group. Yeah, but it can send it to the next group. So this helps with exactly once or at least once processing. Now this also helps to allow multiple independent consumer, because different group ID means independent consumers. So one group can process messages for business logic, another group can log or audit the same message. Both get all messages independently. Alright. Now we are done with the consumer service. Now our producer produces a message, a consumer consumes a message, but a producer expects a message as well. So how do we get this message? So for this we would require a controller between them, right? So let's create that. Now if you see, we are not working on packages for now, because again, keeping things simple. Now this is obviously going to be a REST controller. I don't have to specify more towards that. And the mappings are going to start with API and Kafka. Alright, now here what we need to initialize is a producer service, because producer is going to produce a message. So private final producer service and producer service. Now let's create a constructor. Let's remove this line and we are good. Now we have to have a mapping. So first mapping is going to publish. So public, we are going to get a response back, and that would be in response entity. The type would be string obviously, and the method name would be publish for the same obvious reasons. Now this is a post mapping, so let's specify that, and the mapping is going to be publish, just like the method name. Now here we need to get the message that we need to send, so that we will get as a query. So request param string message, and here we would simply say producer service dot send message and the message, and then we will return response entity dot okay, and let's say message sent to Kafka successfully. Alrighty, now we are done. Now we can run our application to see if it is working fine. Remember, this is just the first mapping and we would see everything in the logs, so we can run this. Java application, let's wait for it. Now what do you see in the logs? This is the most important key thing. Let's highlight on this. So these are the exact same properties which we saw in the terminal. Alright, now the connection is set, server is listening to 9092 port, our application is running on 8080, and if we go down, if you see, we have consumer client ID as consumer Kafka group 1. So if we had more groups, it would have different client IDs. Now the group ID is Kafka group and the cluster is this. Now how do we get this cluster? If you remember, in the terminal we executed one command. Let me go up. So this is your cluster ID that we generated. Now I won't explain everything here, but what you can see basically is that everything is good to go and we can produce a message. So let's open Postman quickly. So like I said, this is going to be a post mapping, local host 8080 API Kafka publish. Now we have to give a query param. So the key is going to be message and the value is going to be hello world. Alright, now let's send this, and what do you see? 200 OK and message sent to Kafka successfully. Now going back, what do you see? Consumed message hello world. Now how would you believe me that the message was produced and it was consumed, right? So let me again give you that overview. So producer produced the message and it was done. It was done doing its task and it stopped. Now thing is that Kafka is now responsible to get this message to a consumer using this Kafka topic. Now in the consumer service, we are using that same Kafka topic and consuming the message. Alright, so that is how Kafka basically works on a real-time analogy. Now like I said, we just have one mapping for now, so let's add another one. So once the consumer is done consuming, we can store that into a list. So let us have a method list string get messages. Now how do we get this list? Let me tell you. So before printing, let's add a variable private final list of string messages equals to collections. Yeah, we need to do this, right? Otherwise how would this work? New array list, this we have to do, this is a must. Now why do we have synchronization? So Kafka consumer service is running in a multi-threaded environment. Kafka uses multiple threads to process messages, and a Kafka listener listens, and this can be called concurrent because this is coming from different threads. Now imagine if one thread is adding to a message, as in adding a message to the list, another thread is reading or adding at the same time, and then it will cause race conditions, corrupted data, or maybe exceptions like concurrent modification exception. So that is why we have a synchronized list, so that everything works smoothly. Now we have this list, so just add items to this list. Alright, now what we would do is we will simply return an array list of messages. Alright, now we are ready for our mapping. So similarly what we have used for producer service, now similarly let's do that for consumer service as well, right? So private final consumer service, and let me add this to the constructor as well. Alright, now we are good to go. So this mapping is going to be a get mapping first of all, and this is again going to return a response entity, but this is going to be a list of string. Let's import list here. Alright, now we would simply return response entity dot OK, and here we would say consumer service dot get messages, and we are good to go. Okay, save this and let's run. Alright, so it's running. Let's come back to Postman and let's do local host and messages change this to get, hit send, and it's empty, which is fine. Now let's send a message and send this one, and you can see hello world. Now here you see a formatting, so you just ignore this. So string value has quotes inside quotes, but if you see here, this is what we have provided as well. So if I just simply remove this, and what do you see? This was the before and this is the after, right? Now, alright, so we are good with this. Alright, so what more we can do here? So let's add few more mappings, like, so these are your new mappings. We have a search, count, and clear. So as the name suggests, this is going to search the messages depending on a keyword. This is to count all the messages as in the size of the list that we have. This is to clear the messages. It's not going to clear a particular message, but clear entire list. Alright, now let's work the behind the scenes functionality for this. Let me save this. I'm going to, so here what we need is, in the consumer service we would like to add two new methods. So first is your clear messages. So this would clear messages, and this is obviously you have to do if you want to clear the messages from the list. And public list string search messages. This is going to be based on a keyword. Now here we have to use the entire messages list, use a stream operation of filter. So filter is going to be based on a keyword. If the message contains a keyword, then collect it to a list. Alright, now we are done. Now let's run this. Let me restart the application. Alright, so let's hit the same message again. Message sent to Kafka successfully, hello world. Now let's say hello Kafka. Let's send this one as well. Let's say Demon Slayer Infinity Castle. I'm waiting for this movie, and let's send this. Now we have 3 messages, so let's see. Alright, so we have 3 messages. Now what should we do? First let's try for the, so let's first do count of messages. So I think it's just this, and you got 3. Now let's do search. So search is again a get operation. Let's do search here, and it expects a request param again. The name is keyword, so let's say hello. Now in this case it should return 2, and it returned nothing. Why? Okay, it's capital H. Okay, so now we know that it works. And Timon. Alright, so it's working fine. Now let's clear everything up. Use delete operation. Localhost 8080 API Kafka and clear. Message list cleared. Now if I try to fetch the messages, there isn't anything. So this was it, what I wanted to achieve with this video. I hope you learned something about Kafka and your integration of Kafka with Spring Boot. So remember here, what happens is if I stop my Kafka or if I restart my Spring Boot application, whatever you have in your messages list, it's going to be cleared up because we are not saving anything anywhere. So you could have a file system where you could have saved it to a file or S3 or maybe a database, right? So this we don't have, but this can be easily integrated, and I would try to create one more video to have basically a UI integration or a database integration. So I'll make more videos if you guys are watching this video, as in if this is getting hits, then I'm okay with creating more videos, but if it is not, then I'll switch to some other topics. So this was it for this video. I really hope that you learned something new. If you did, don't forget to like, share this video and subscribe to my channel, and I would meet you in some another video. Till then, stay happy, keep learning, and bye bye.